Hello everyone, welcome to IMS Academy. I hope you are enjoying our YouTube sessions for your GATE examination. Today I will be taking a session on engineering mechanics and we will be discussing some of the important questions, I would say basically the challenging questions for engineering mechanics. So this question will help you to build your concept as well as these are most likely questions that may come in your GATE 24 examination. So this is the last practice that you should do for engineering mechanics. Okay. Now, before starting the session, guys, I want to just tell you about the live online program here. We have a live online program having 800 hours of sessions, and apart from that, theory and exercise book and previous year question bank you will be getting, and apart from that, 12 one-to-one mentorship sessions you will be getting, and online test series. And the most important feature is the doubt solving support that is 24/7 available. You can post your doubts in the doubt solving portals. So you can definitely check out this live online program, and if you want to book a counseling session, free counseling session, you can call on these numbers as well. Right. So let's get started in the session. Right. Okay. So we'll start with the numericals only directly, and the top 10 questions I have selected for you. Okay. So we'll be solving such questions. And before solving this question, I would first ask everyone, please try to attempt this question, and I will give you the 2 minutes for this question. Then we will start doing the solution of this question. So everyone should start solving this question. I will give you 2 minutes here. So let's get started, everyone. With the timer, we will be solving all the questions. Okay. So start solving, everyone, fast. You have 2 minutes for this question. So 10 challenging questions we are going to discuss in engineering mechanics for your GATE 2024 examination. So first question is from the Truss analysis, and they are asking the force in member HG. Everyone, just try and tell me your answers. Last 1 minute. See, we'll be solving this question with the method of section only, right? And time up here. Okay, now see the solution, guys. They are asking the force in member HG. So remember, in method of section, what we are going to do, in method of section, we will be using a section through which I will cut the truss. And remember the important point, we should cut the truss in such a way that it should not cut more than 3 members. And what is the reason behind that? Reason is we only have 3 equations of equilibrium, and at a point of a time, we cannot solve more than 3 unknowns. So you should cut a truss with such a section such that it should not cut more than 3 members. I hope this point is clear, because we have only 3 equations of motion. 3 equations we are having for equilibrium here basically. Now this is the section we are going to use. So 3 equations of equilibrium: summation of force along horizontal 0, along vertical 0, and summation of moment 0. These are the 3 equations of equilibrium. So this is the section I have cut. I need to calculate force in member HG. So let me just draw the cut part. Let me take the left part first of all. Okay, if I take the left part, so it will be like this. So this rough diagram I will be drawing. So this is force in member Hg. That is what I need to find out. Apart from that, this is 5 kilonewton acting here. This is 2 kilonewton acting here. Okay. Now, let me just mention the names as well. This is the point B. This is point A. And at point A, some reaction Ra value will also be there. Right. Now, how I will be able to solve this question? Karthik, you are telling 20. Okay. We'll see whether the answer 20 is correct or not. Okay. So, this is the diagram we will be having. The left portion I am going to analyze. But before analyzing the left part, I need to know the value of Ra. I need to find out the value of Ra, support reaction, right? So, what I will do, in order to find out support reaction Ra, I will take the moment about point E0, okay? Let us take the summation of moment about point E0. So, if I do that, what I will be getting, see, reaction Ra, okay, it will be vertically upward, it will have a clockwise movement about point E. What is the distance? Total 8. So, Ra multiplied by 8, okay? This is the first thing. Apart from that, we have this 2 kilonewton, 5 kilonewton and this 5 kilonewton. These all are having what? Anti-clockwise movement. Are you getting my point? Ra, which is vertically upward at point E, it is having clockwise movement. This 2 kilonewton, 5 kilonewton, 5 and this 5 all will have an anti-clockwise movement. So, I will be writing here this 2 into 8 plus then we have 5 into 4, okay. 5 into 6 it is, not 4, it is 6. 5 into 6, then again 5 into 4, then 5 into 2. Then finally we will be having 5 into 2. Right. So from here you will be getting support reaction Ra value. First of all, tell me the Ra value. What is the Ra value you are getting? Karthik, can you just tell me what is the value of Ra you got from here? Can you just tell me what is the value of support reaction at point A? Its calculation is very simple. Na? This 2 into 8, 16, 5 into 6, we will be having 30, then 5 into 4, 20 and 10. Resulting answer, support reaction will be 9.5. Okay, please cross check your answers as well. So, support reaction Ra we have found out. Now, finally, how we will be able to solve this question? Which equation of equilibrium we need to apply here? As I told you, summation of force along horizontal 0, summation of force along vertical 0 and summation of moment equals to 0. These are the three equations. Out of these three equations, which equation I need to apply here to get the answer in force in member Hg? Which equation I should use here? So that's what we need to understand when we are applying a method of section problem concept here. The point is which equation I need to apply. If I have not selected the correct equation, definitely I will be wasting time in solving such question. This method actually need what? Hardly 1 minute to solve question. Right? But for that you need to select the correct equation of motion. So, see, summation of forces horizontal I cannot take because there will be this unknown force BC and unknown force in BG as well, which I don't know. The only unknown Hg, that is what I need to find out. Other unknown, I don't know the values. See, other unknowns like force in member, this BG. Force in member, this BC. So, these are also the unknown. Keep in mind, these are also unknowns. Summation of force vertical, again I cannot take because BG will also have a vertical component. Two unknown in one equation we will not be able to solve. So, I need to use that equation in which only one unknown should be there and that unknown should be force in member Hg. Please keep this point in your mind. We have to find out force in member Hg. So, in your equation only Hg should be the unknown. Other unknown should not come into your equation part. Very important point. So, what I will do here, I will take the moment about point B. If I take the moment about point B0, I will get the answer very easily. So, about point B if I have to take, so first of all this this Hg, the angle Hg, this angle theta will also be the same angle this theta, right. So, FHG cos horizontal component I will be taking. FHG horizontal component. The horizontal component will be written as FHG cos theta. So we'll write force in member Hg cos theta. So it will have a moment about point B clockwise. 5 kilonewton will not have. Vertical component of Hg will also not have a moment about point B. Both are passing through point B only. 2 kilonewton will have a moment about point B in anti-clockwise sense, but Rb will have a clockwise sense. Sorry, Ra reaction. So we will write Ra into distance what 2, and only this 2 kilonewton is having an anti-clockwise moment about point B. So 2 into 2. Ra value 9.5 already we have calculated. What about cos theta? Remember here, whenever the triangle dimensions are known, no need to find out theta. Directly write cos theta value. This is the theta, na? So base upon hypotenuse, this is the perpendicular. Base is what 2 and 2, that is 4. Hypotenuse will be what 5. Hypotenuse will be what 5, na? This is very important point. Now one more thing, f cos theta, distance we have not multiplied here. So let us just multiply the distance as well. Let us multiply the distance because we are writing the moment values. Force in member Hg cos theta multiplied by 1.5. Total is 3, just half will be 1.5. Cos theta value is 4 by 5. Let me just write it. Cos theta value is 4 by 5. This thing. So from here you will get the answer very easily for the force in member Hg. Force in member Hg you will be getting very easily, okay, from this equation. So here we need to understand how we can take one equation from which I will get the answer. How to identify which equation will give us the answer without calculating other unknowns. That is the main thing. Without calculating other unknowns, how we will be in a position to get the answer of that particular unknown. So we'll be using that equation in which other unknowns should not come into that equation, which means other unknowns are not the part of that equation. So and we have to figure out which equation will be the correct equation here. So finally, force in member Hg. Please everyone tell me what is the final answer of force in member Hg. Force in member Hg will be, it is finally coming out as 12.5. Okay, please cross check your answers. 12.5 kilonewton. Now answer will be coming in negative, which means we have to change the direction. So that's why in Truss analysis problem, never you should be worried about the directions. Whatever direction you have assumed, based on that, if your answer is positive, it means direction was correct. If answer is coming negative, it simply means you have to just change the direction because that direction was wrong. So please don't worry about the directions. You can consider any direction. Like I have considered all away from the joints, all the unknowns. I have not basically give a thought about that whether it is away or towards. We don't need to do that also. Because from the final answer we will get to know whether it is correct or not. Positive answer means assumed direction was correct. Negative answer means the assumed direction was wrong. So just we need to reverse it. That's all. Right. Now let us move to next problem. Right. Yes, this one. This is from the dynamics part. And mostly we'll be discussing the dynamics questions here. So this is the question next. So this is a sliding plane. At this point it is having 30 degree. Here it is having different angle, 15 degree. Right. Okay, so they are asking the like first of all the assuming coefficient of kinetic friction we need to assume here. Next thing is they are asking the acceleration of package at point B. Acceleration at point A they have given, okay, that is 3 meter per second square. Acceleration at point A they have given, but acceleration at point B they are asking, and we have to assume same coefficient of kinetic friction. Obviously kinetic we need to take because it is under motion, right? So apply equations of equations here. Equation obviously motion, equation of motion we need to apply here because it is under motion condition. Equation of motion you need to apply and tell me what will be your answer. Okay, so let me give you the time here for this question again, 2 minutes. We need to be very fast, okay, in solving such questions. First of all, after reading the question only, you should please think about the approach. What are the formulas and the relations that we need to use here? Okay, And in engineering mechanics, I always always tell this point every time in the classes also. Please draw the free body diagram. Please try to draw the free body diagram. Then only we can do the analysis, whether it is under static condition or in dynamic condition. The first and foremost thing is draw the free body diagrams. So first of all, you should draw the free body diagram of A. Then apply the equations of motion here, as it is under motion. Right? Do it everyone fast. This will be the free body diagram. Just let me know everyone, is it clear? The force, the weight component will be mg cos theta, mg sin theta, normal reaction force, friction force. Right, so free body diagram is done. So then apply equation of equilibrium. Apply equation of equilibrium. So, okay, time up. The point you need to understand, the motion is along the incline, perpendicular to incline, there is no motion. So what I will do here, I know the motion is along the inclined plane. So perpendicular to inclined, what will happen? Summation of forces will be 0. Summation of forces will be 0. So from here, I will be getting this normal reaction equals to mg cos theta. Right, now next equation that I need to apply here is summation of forces along the inclined plane. Along inclined plane equals to mass into acceleration, as it is a case of motion, dynamics case. So mass into acceleration it will be there. So this is the first equation, this is the second equation. So perpendicular to inclined plane, there is no motion. Along the inclined plane, the motion is there. So we will be writing the Newton's second law. Basically, mass into acceleration will be coming. Now, so let us just write this equation here. So first of all, along the inclined plane, mg sin theta is there, minus this mu k into n, which is nothing but mg cos theta only. So directly I am writing mg cos theta here. So this is the forces, net forces along the inclined plane, which will be equals to m into acceleration part, which will be equals to m into acceleration. Now from here, the simplified relation, okay, just simplify this equation. M will get cancelled out. This m will get cancelled out with this m. So acceleration will be g sin theta minus mu k cos theta. So this is the acceleration relation. Now at point A, the angle is what? 30 degree, right? Acceleration value already given in the question, 3 meter per second square. We will be putting the values. So which particular parameter we will be getting from here? We will be getting the answer of coefficient of friction, kinetic coefficient of friction directly. So A value 3, G value 9.81 will be keeping here, sin 30 value. Minus mu k cos 30 value. So from here, mu k answer you will be getting. Now this mu k value is what required here to get the acceleration value at the point B. Acceleration at point B they are asking. Okay. So first calculate the coefficient of kinetic friction here. So please everyone solve this one and tell me what is the mu k value you will get from here. And after that, what we need to do, simply in this relation only, theta we have to change 15 degree, mu k already we will calculate from this equation. What will be the answer of mu k here? what will be the answer of mu k value? So already I have written everything here in this particular equation here. Main final equation also I have written. You just need to put the values and tell me the answer of mu k. Okay, tell me your answers. This G, this bracket side will be coming here. Like this. Like this it will be there. Because G is what common na, from both the parameters. G sin theta, mu k into G cos theta. So G will be coming outside. So bracket will be here only. Point something it will be there. Anyone has solved? 0.22. Final answer. Let me tell you the answer of kinetic coefficient of friction is 0.22. Now this value and theta 15 value we will be putting in the acceleration relation. So acceleration relation is G sin theta minus mu k cos theta. This is the relation that we have developed. Okay. This is the relation, acceleration relation we have developed, G in the bracket sin theta minus mu k cos theta. Now mu k value 0.22 and theta value is 15 degree. Okay, from here acceleration answer you will be getting. Right? So in dynamics, see quotients, you will definitely have a feeling that okay sir, something new kind of quotient came, but I'm telling you the concept will remain same here. So you need to understand what the concept. Okay, first of all the concept is there, then second you need to understand what actually happening in the question. In the question they have given, right, there is a block sliding in the plane. So block sliding, so first of all I will draw the free body diagram. Once I have drawn the free body diagram, then I can easily understand what kind of motion it will have. Then according to its motion, I will apply equations of equilibrium or equation of motions. Based on the motion, whether it is having motion or not, so then equation of motion I will apply. If it is having motion, if it is under equilibrium, equation of equilibrium I will apply. So it's all about the equations depending upon the condition that body is having. Right? So that's why we have applied the equation of motion here along the inclined plane, perpendicular to inclined plane. It is not having any motion, so summation of force is 0, from where we'll get n equals to mg cos theta. And finally acceleration relation we got it, right? So finally if you put all those values here, you will get answer approx 0.45 meter per second square. This is the final answer here, 0.45 meter per second square. So in dynamics, what should be your approach here? Whenever you read the question, just draw the free body diagram and try to understand what kind of state it is. First of all, what kind of state it is having, static or dynamics. If it is having dynamics, so what kind of motion it is having, translation or rotation or combination of translation and rotation. Are you getting the point? First of all, the first thing is condition, state, whether static or dynamic. Static is there, so equation of equilibrium. Then dynamic is there, we need to understand it is having a translation motion or rotation motion or combination of translation and rotation. So accordingly, we will be apply equation of equilibrium or equilibrium of motions. I know here it is having a translation motion. There is no rotation about in this particular example or in this question. So translation equations I have applied. So we need to understand the motions as well, right? So let us move to next problem here. This one. Again similar to the previous problem only, but some another data they have given in this question. Like a block of 1 kg mass slides down on a 30-degree incline. Okay, 30-degree incline is there through a distance of 10 meter in 3 seconds. So within 3 seconds it has moved 10 meter. Within 3 seconds it has moved 10 meter here. Okay. Determine the coefficient of kinetic friction between the contacting surfaces. Now again here, first of all the free body diagram, same thing we will follow here. Mg sin theta, Mg cos theta. This is the normal reaction force. This is what the friction force. Friction force, again it is in dynamics condition, so mu k will be there like this. Done. Free body diagram I have drawn. Now the data they have given is distance it has traveled as 10 meter. In what time? What is the time taken? 3 seconds. 3 seconds, right. Now very important point, the forces acting on this body, are these forces constant or variable? The forces acting on the body along the inclined plane, are these forces are variable or constant? Will these forces will change as the motion happens here, or it will remain same? Weight component mg sin theta, it will not change. Friction force value, it is not going to change. So the net forces is not going to change, then why the acceleration is going to change? So the basic conclusion here is acceleration is constant here. So the net forces, okay, first of all you need to understand this, net forces equals to mass into acceleration. I will apply this. This Newton's second law will apply. So from here I can say the net forces remain same. So then why the acceleration will change? Acceleration is constant. Now acceleration is constant. Once we have figured out, like if acceleration is constant, then constant acceleration, for constant acceleration we have three equations of motion. I hope you remember. S equals to u into t plus half at square. This equation is valid when the acceleration is constant, and acceleration constant is not mentioned in the question. That point you need to understand from the question only. And how you will understand? When you will draw the free body diagram. Just by reading the question and observing the diagram will not help you out. So please try to understand acceleration constant is there, and I have to use this equation. Who will tell? I will apply, I will first draw the free body diagram, then I will see what are the net forces. Net forces mg sin theta and this friction force are not going to change along the inclined plane. These forces are constant, so then acceleration will also be constant. Acceleration will be variable if these forces are variable. Forces constant, acceleration constant. Acceleration constant, this relation I will use because the data, time and distance they have given. So distance 10 meter, initial velocity will be assuming 0, okay, because it is having a motion from the rest condition. Half at square. From here acceleration into time t, that is 3 square. From here acceleration answer you will be getting. Once acceleration answer is we have finally, then I will put here and I will get the answer of mu k as well. Finally I will be getting the answer of mu k as well. I hope this point is clear to everyone. So first calculate acceleration, then use that acceleration value in this Newton's second law, that is equation of motion, right? Do it fast everyone. Do it everyone fast. So it becomes 20 divided by 9 it will be there. Okay, so it will be approximately 2.22 meter per second square. That acceleration value I am going to use, and net forces along the inclined plane I am using. So mg sin theta minus mu k into n, that is the net force, equals to mass into acceleration. Only unknown in this particular equation is mu k, kinetic coefficient of friction. Okay, so replace n with mg cos theta, because what I will apply equation of summation of forces along the perpendicular direction, along a perpendicular direction to inclined plane. So as it is not having a motion perpendicular to inclined plane, so summation of forces will be 0. So n equals to mg cos theta, that you will be getting. So n value mg cos theta you need to put it here to get the answer of mu k. Right everyone? From here mu k answer you will be getting. Do it fast everyone. Final answer is for kinetic coefficient of friction. approximately 0.31. 0.31. Right? This is the answer here. So I hope you're getting the approach here, like how to attempt dynamics problem. In dynamics problem, the main first thing is draw the free body diagram. After drawing the free body diagram, please try to understand what kind of state it is. The system. Think about the state of a system. Then according to its state, you have to apply the equations, whether it is static or equilibrium or static or dynamics. Based on its state, we need to think about the equations, and then we'll apply that equation to get the answer. Right? So never ever you have to worry about the dynamics problem. You have to read the question, draw the free body diagram, think about its state, think about the equations that you need to apply here, and you will get the unknown answers, whatever they're asking. Right? So let us solve some few more questions here. So in this question, we are talking about the translation only. Now next problems, we'll be talking about the rolling as well, which is a combination of translation and rotation. Till now, whatever last two questions that we have solved, that are totally from the translation point of view. But this question is from the rotation plus translation. That is what the rolling here. Right? So what they are asking, acceleration of a disc rolling without slipping. So let us take, or let us derive a general relation which will be valid for ring, for a disc, solid sphere, hollow sphere, any kind of object it will be valid. So let us derive an expression here, and that expression you should remember for your examination. You can expect direct question from that relation here. Right, see, but first of all here the forces, again free body diagram. So here only I will show all the forces. Here only I will show the forces here directly. So this is your mg cos theta. This is normal reaction, right? This is mg sin theta. This is your friction force. Right? These are the forces that will be acting on this particular disc. A disc is there, sphere is there, whatever. Now, as I told you, under rolling case, rotation, translation both happens. So for translation I will write separate equation, for rotation I will write separate equation. Okay, remember this point. So rolling without slipping here, that is also very important point. I am coming to that point also in the later part of the solution. Rolling without slipping, what actually it means. So see, first of all, for translation we will be writing summation of forces mass into acceleration. That is what equation of motion for translation. Equation of motion for rotation will be summation of moment equals to mass moment of inertia into alpha, that is I into alpha. Equation of translation, equation of rotation, two equations we are having. Now what are the forces we will have? mg sin theta minus friction force equals to mass into acceleration. Fine, okay. Mass moment of inertia, okay, into alpha is there. Now what is the moment? Moment will be created at the center because of friction force. Friction force, because of this friction force about the center there will be a moment value or the torque value. So this friction force multiplied by radius r will be the moment or the torque, which is what provided by the friction force. No? The torque about the center is provided by the friction force. Friction force is providing the torque at the center, which will induce the rotation here. Mass moment of inertia, I will keep this as mass moment of inertia m only into alpha. Clear? So these are the two equations. Now disc rolling without slipping means it is a case of pure rolling motion. And what is the condition of pure rolling motion? The center of mass of a disc which is having pure rolling motion, it will have a velocity r into omega, acceleration will be r alpha. The condition of pure rolling, okay, I hope you should remember this point. Okay, so please everyone try to remember this condition of pure rolling here. condition of pure rolling. Center of mass will be having r into omega velocity, and acceleration of center of mass will be r alpha. Acceleration of mass, which mass? Center of mass. So always remember, whenever we are writing Newton's second law, it is always acceleration of center of mass. Got it? Now this alpha can be removed here and can be written as acceleration of center of mass divided by r. Now I will use this value in this equation to get the friction force value. So let us give us the name of equations here. Equation 1, equation 2. Okay, now from equation 2 here, I can write friction force value equals to, friction force value will be equals to mass moment of inertia value divided by r into alpha. Now alpha can be written as acceleration of center of mass divided by r, like this. This is the friction force value. Now this friction force value I will put here in equation number 1. In equation number 1 I will be putting from equation 1. Right, this mg sin theta. Okay, mg sin theta minus friction force. Friction force is mass moment of inertia into acceleration of center of mass divided by r square. Right, and here it is ma. Now we have to find out the acceleration value, so we will write it like this: ma plus this mass moment of inertia into acceleration of center of mass divided by r square. So this is also center of mass acceleration. Equals to mg sin theta. So acceleration of center of mass will take common here. It will be m plus mass moment of inertia into divided by r square basically, equals to mg sin theta. This is there. Then finally we will be having acceleration of center of mass as mg sin theta divided by small mass m plus mass moment of inertia divided by r square. So this is the relation that we will be having. Okay. So acceleration value of the center of mass of a disc, sphere, ring, or whatever kind of a body we are having, we can directly get the answer of acceleration from this equation. So you just need to put the mass moment of inertia value. Now let us assume that it is a case of disc, as it is mentioned also. For example, we will be taking for disc. For disc we will be having mass moment of inertia value about the center as mr square by 2. So acceleration of center of mass will be mg sin theta divided by m plus mr square by 2 and this r square. So r square will get cancelled out. R square and r square will get cancelled out. So mg sin theta divided by this m plus mass moment of inertia divided by r square. So finally center of mass acceleration. So if I take the LCM here, it will be 3m by 2. So 2 will go to the numerator. So m will get cancelled out here, 2g sin theta divided by 3. That is what the relation of acceleration for the disc will be having. Yes or no, everyone? Is that clear? So that is what the acceleration of center of mass 2g sin theta divided by 3. Done? Now, okay, now one more thing I want to tell you here. Now, once you have calculated the acceleration value, Once you have calculated the acceleration value, you can calculate the distance traveled, time taken to travel that much distance, because that acceleration value will remain constant. So next thing is what, when this acceleration value remain constant, then you can use s equals to ut plus half at square, v square is equal to u square plus 2s, v equals to u plus at. The three equations of motion when acceleration is constant, that part you can apply here to get the answer. Got it? Now moving to the next part, next question guys. Now again, as I told you, in starting we have solved the translation problems. Now we'll be moving to the questions in which rotation is also get involved. So this is one of that question. Okay, this is one of that question in which rotation is involved here. Everyone, see, in this question they are telling a thin uniform bar of mass m and length l suspended from two vertical inextensible strings if the right hand string BD. So this is BD and this is AC. Right. Now see, so they are telling if string BD is cut, if string BD is cut, then find the tension in the left string AC. If I cut this string BD, what will be the tension in the string AC? Now I need to do what? Again, I'm telling you the approach in all the problems. Every problem of dynamics have the same steps. Whatever information they have given in the question, whatever diagram they have given, and whatever they have told, according to that we need to draw the free body diagram. So the step first is draw the FBD here. Okay, so let us draw the FBD part here. Right, now see, it will be having a tension T here. This is the center of mass of this one, which is having weight W equals to mg, right? This will be the free body diagram. Yes or no? This is the free body diagram. Okay, so this is the rod we are having. This is what the tension it will be acting at this point because of the string at point, string at AC. AC string will be having what, the tension at this end A. So this tension basically they are asking, tension in the string AC. Now you should tell me what actually will happen here if I cut this string. What will happen? Okay, tell me what is going to happen here if I cut this string. What kind of motion it will be having? You have to give a thought actually here. What kind of motion it will have if we cut the string BD? Obviously it will do what? This kind of rotation. Rotation will happen about this point. Na? If I cut the string here, what will happen? Initially it was horizontal, then it will turn like this. Right? So this is what we need to understand from the question language. Is that clear? So now we will be applying equations of motion here. We will be applying equation of motion here. Done everyone? Now see. Summation of forces first of all equals to mass into acceleration. That is the first part I will use here. The net forces in this case will be mg minus tension T equals to ma, and basically tension T I need to find out, so I will write it tension T equals to mg minus ma. So that is the first equation. Next, summation of moment equals to mass moment of inertia multiplied by alpha. So let us take the moment value about which point? Center point only. Now you will be saying, sir, why at the center point you are taking? Because actually I want to find out tension. If I take the moment here itself, then tension will be 0. the moment because of tension will be 0 na. That's why I'm taking this center point. I'm writing moment about point this C. Not right, we will not write C because already we have written C here. Let us take this point as G. Let us take this point as G. About G I am taking the moment. So tension will be having a moment here. What is the moment because of tension? Tension into this distance, half of the length. Half of the length, so it will be L by 2. Simply we will take L by 2. Now, the mass moment of inertia about this G for the rod will be ml square by 12. I hope you remember this formulas into alpha. This is the formula here, right? Yes or no? So from here you will be getting the alpha answer here. Alpha value you will be getting. From here you will be getting the alpha values. Just simplify and you will get the answer of alpha value. And one more thing, okay, what is the acceleration for this center of mass? What will be the acceleration for this center of mass? Can anyone tell me? What will be the acceleration for this CG point, center of mass point? What is the acceleration value? Anyone? Because that is what required here. Okay, that information is required. Without that information we cannot solve. So just let me know about the value of the acceleration that center of mass will be having. Everyone please try and tell me your answers. How much acceleration it will have? It is having a simple acceleration r into alpha na. See, this is the center point. So when you will cut here, the center point is what having under rotation about this point. So what is this tangential acceleration it will be having? R into alpha. R is what? L by 2. Are you getting the point? So understand, when you have cut this one, the center point is rotating about point A. The center point is under rotation about point A. So this is the point of rotation. About this point, the center CG of the rod is rotating. So the tangential acceleration that it will have is R into alpha. In rotation we have discussed. Absolutely, Vinay Kumar, correct. Your answer is correct. R into alpha, R is what? L by 2. Okay, so that is what you need to understand, right? So now, so what we will do here, better we will do what? Put the value of tension here itself. mg minus ma. A value also we have written. Okay, so see, T value is what? mg minus ma. A will be written as L by 2 into alpha. That is tension value, mg into ma. A value is L by 2 into alpha into L by 2 ml square by 12 into alpha here. Now this L, 1L will get cancelled out here. This 2 will get cancelled out with the 12, so we'll write there 6. Okay, so remember this acceleration R alpha. Okay, keep in this mind this information also. Now just simplify this equation. So mg minus m into R alpha, that is L by 2 into alpha. M into L by 2 into alpha, and here it will be ml alpha by 6. So first of all, again this m is common, so we'll remove this part, m part. Okay, so here g minus it will be L alpha by 2, and here it will be L alpha by 6. So g value equals to L alpha by 6 plus L alpha by 2. So if I take the LCM here, what I will be getting here? See, I will multiply and divide by 3 here, so it will be 4 L alpha by 6. Okay. Now if you just simplify here, it is 2L alpha by 3, and finally we can write here alpha value, because we are concerned with the alpha value. In this question also they can ask, one more question can be created here, and they can ask angular acceleration, find out the angular acceleration. So keeping in that mind also I am writing this part. So alpha value will be written as 3g by 2L. That is what radian per second square. So that is one of the unknown parameter we have solved here. Done everyone? Till this point everyone, is it clear? 3g by 2L. Yes, yes Vinay Kumar, correct. 1.5 g divided by L we can write here. Done? Now this was the equation we have written, the moment value about the g. So let us give the name here. This was equation 1, this was equation 2. From equation 2, let me just write it here. Tension T into distance L by 2, yes, correct. Mass moment of inertia ml square by 12 into alpha. Alpha value I will write here 3g by 2L. From here tension value you will be getting. Okay, from here tension value you will get finally. Now tell me what is your final answer. Final answer after solving this question. Tell me what is your final answer here. What is the final answer after this? Just simplify this part. So this 2 cancel out, 3, here it will come 4, LL will get cancelled out, it will be mg by 4. That is the answer here finally, right? Done? Yes, correct Vinay, correct. 0.25 into m, but g also you should write. Now next question guys, similar to that only, again similar to that one only, but in this question they are asking, please understand, they are asking the instantaneous tangential acceleration. Yes, correct Vinay. Tangential acceleration of the center of mass in the horizontal position. Again in this case, if I cut this spring, so when it comes to this horizontal position, at that point they are asking the center of mass tangential acceleration. Tangential acceleration of center of mass they are asking. Again you know that tangential acceleration we need what? R into alpha. Alpha value is what main important here. Alpha value if you have solved, then we will get the answer here. But how we will get the alpha value? That we need to understand. Okay, we can solve this question but in a different approach also. I will give you the answer of this one in a different approach. Not similar to that just now we have done in the previous problem. Whatever we have done in the previous problem, same can be done here also, but I will solve this question with different approach. Okay, but I will give you 2 minutes here to solve this one and let me know about your answers. Two minutes for you, please everyone, and tell me your answers. Alpha answer, everyone. Alpha value is the main important part here. If you are able to find out alpha, then tangential acceleration is r into alpha only. Last 10 seconds. Tell me, anyone has solved this question? Okay. When you will cut this one, when it will come to this horizontal position, at that point, so let us just draw the rough diagram here. This one is what the weight mg. So the torque about the point A, point of rotation basically. So if I am applying the Newton's second law for this rotation, moment value will be mg into L by 2. Simple. Mass moment of inertia about point A. So one of the end of the rod, mass moment of inertia value is ml square by 3. So please everyone, you should remember this formula directly. ml square by 3, direct this formula you should remember, into alpha. To calculate the mass moment of inertia about the center of a rod, it is ml square by 12. But one of the end it is ml square by 3 using parallel axis theorem you will get. So from here alpha value. So what will happen? See, alpha value we need to find out. This mm will get cancelled out. It will be 3g. 3g by 2l. Okay, this is 3g by 2l radian per second square. Got it? 3g by 2l it will be there. Now this is only we needed here to solve it. Tangential acceleration of center of mass r alpha. R is what? L by 2 multiplied by alpha 3g by 2l. So it is 3g by 4 meter per second square. Correct everyone? Now 3g by 4 it will be there. Done. 3g by 4 is the final answer here in this question. Okay, we'll move to the next problem, everyone. Next problem. So again, I'm telling you, in dynamics problems, most of the students face a lot of challenges in the dynamics problem. But again, simple solution I'm telling you. You need to first understand the question, then draw the diagram. Which diagram? Free body diagram, FBD. And understand what kind of situation it is. The body is having what kind of condition, static, dynamic. Then accordingly we will apply equations of motion if it is under motion, or equation of equilibrium if it is under equilibrium. So that is what we need to understand, everyone. So what I have done, I know that they have told, okay, it is cut in horizontal positions, they are saying. So let us draw the horizontal position of a rod. At horizontal position, about the center, mg, that is weight will be acting, that will have a moment about point A is what? Mg into L by 2, mg into L by 2, I into alpha. So about the point of rotation only, we will be writing mass moment of inertia, right? So ml square by 3, not ml square by 12. Usually many times I have seen students have done the mistake, ml square by 3, sometimes ml square by 4. Or ml square by 12 they put. ml square by 12 is the value about the center of mass of a rod. But if I have to calculate mass moment of inertia about one of the end of the rod, it will be ml square by 3 using parallel axis theorem. Right? So that basic point you should remember. Now coming to the next problem, everyone. This one. Please everyone try this problem. Next. So what they are asking, determine its angular velocity when it has made 2 revolutions. Okay. So there is a disc having a mass 20 kg subjected to a couple of varying moment, not actual fixed moment. It is a varying moment. Okay. So 2 theta plus 4 if it starts from rest. Okay, it is starting from rest. Now see, this equation you should remember, work done equals to change in kinetic energy, also applicable in rotation, also applicable in translation. Work done will be m d theta 0 to what is the final rotation they have given, for initially 0, then finally it is having 2 revolution. One revolution is 2 pi, so 2 pi is for one revolution and here it is 2 revolutions, so we will write 2 into 2 pi. Kinetic energy half I omega square final minus half I omega square initial. Now it is starting from rest, so this is what we will have as 0. It is 0. Right, so what is the value of moment they have given? So 0 to 4 pi, it is there. Moment value is 2 theta plus 4. Okay, it is half I omega square. Which omega square? Final omega square. So this is what we need to do here. Just integrate here, 2 theta square by 2, 2 will get cancelled out to theta square plus 4 theta. Just put the values and calculate the omega f value finally. So here it will be theta square plus 4 pi after integration. Limit is from 0 to 4 pi. And it is half I omega square. I is what for this particular test? mr square by 2. Okay, r is what the radius they have given 300 mm. So 0.3 we will be keeping that value. Mass 20 kg already it is given. Now everything is given, just we need to find out omega f final answer here. Omega f final answer we need to calculate. Okay, just do the final calculation everyone. Just do it the final calculation part. Right. So this relation work done equals to change in kinetic energy. It is also used in translation, also used in rotation. But how we are writing for translation and how we are writing for rotation case, you should understand the difference. Right. So final answer of omega f is 21.5. Okay, 21.5 radian per second. radian per second. Now moving to the next problem, guys. Again, very important formula, important question basically here to calculate angular acceleration of a rod. This is very important question. Vinay, it is 21.5. Just cross check your calculation part. Final angular velocity will come around 21.5. So please cross check your answer. Okay, just cross check your answer here. And this thing 2 theta plus 4 was there, 2 theta plus 4, and here it is 4 multiplied by this thing will come na. Here it will be 4 theta. I have written directly 4 pi here, but it is 4 theta like this. Maybe that's why you are getting 10.5. So integration if you do here, 2 theta square by 2, so 2 and 2 will get cancelled out, 4 becomes 4 theta. I have written directly 4 pi instead of 4 theta. So that maybe because of that you will get 10.5. So please cross check, answer is 21.5 only. Okay Vinay, make sure that you are putting correct values here. So theta square plus 4 theta, right? Now let us will move to the next problem here. Done? Is it done? Then we'll move to the next problem. Okay. Now this one, very important problem here. Calculate the angular velocity of a rod AB. Usually in the gate examination, how the question they have asked, calculate the velocity of any other point or calculate the angular velocity. They have never asked this question till now in the gate examination about the angular velocity. So this is one of the most possible question that might come in your gate 2024 examination. Okay, so please be careful. Okay, please try to understand the approach here, how we are solving this question. Now, so first of all, again, the main point here is the information they have given. So first of all, I hope everyone knows the I center point. So this point B is moving downward, A is moving like this. So the I center, this is what the I center we will be having. This is the I center we will have. So what they have given, the acceleration and velocity as well. They have given acceleration and velocity as well. Yes, great Vinay. Yes, 21.5 was the correct answer. So at a given instant, top point B. So velocity of point B they have given. Okay, acceleration also they have given. So velocity was 4 meter per second. Acceleration of point B they have given as 2 meter per second square. Got it? Now first of all we calculate the angular velocity here. How I will calculate? Velocity of point B can also be written as distance of point B from the I center. Let us write it as IB multiplied by omega, angular velocity of the rod AB. In order to write the velocity of any point, okay, with the concept of I center here, I need to write down the velocity of point B. So distance of point B from the I center I need to take multiplied by the omega of a body. So from here velocity was 4, distance, what will be the distance? 16 cos 30 degree. Okay, 16 cos 30 degree. 16 horizontal component, 16 cos 30 it will be there, multiplied by omega AB. So from here omega answer you will be getting for the rod AB. That is very basic thing, you can easily do it. Now the point is how I will get the angular acceleration. How I will get the angular acceleration. Okay, so let us understand here the concept. It is having acceleration 2 meter per second square. Velocity also in the same direction 4 meter per second. Okay, fine. So this is point A, this is point B. Now very important point. What I will do here, I will write down the acceleration of A considering B as a reference point. Considering B as a reference point. Why B as a reference point? You should ask this question. B as a reference point because for B we have the information of acceleration. That's why for writing the acceleration of A, I will consider B as a reference point. So I want to write down the acceleration of point A with respect to B. So B is a reference. So I am sitting on point B and I am observing A. That is what it is having the meaning. Reference means what? At point B, I will observe point A. By sitting at point B, I will observe point A. Right? This is the main thing. So this is the equation. Acceleration of A equals to acceleration of B. Okay. This is vector addition. Remember this point. Now, if I ask you what kind of motion A will do if I am sitting on point B. If I am sitting on point B, what kind of motion A will have? If you are sitting at point B, what kind of motion A will have? Rotation. And rotation will have two components, tangential and acceleration. Right? In absolute sense, I know point B is what? moving in the vertically downward direction. It is sliding. Correct. Absolute sense. In absolute sense, sliding will be there if I am observing from the reference outside of this plane. From outside, if I am observing, I know B is what, sliding vertically downward, but or A is sliding towards left. Correct. But if I am standing at point B, okay, I am sitting at on the ladder only. I am sitting on the ladder at point B and I am observing A. So that is what, where we call it the relative motion, that will come into picture here. I am sitting on one of the end of the ladder, that is point B. I am sitting at B point of the ladder. So, and I am observing A. So while it is having a motion, I am also moving. So with respect to me, A will be under rotation point. A will be under rotation. Right. So this information you should understand, because here we are talking about the relative motion. Got it? So in absolute sense, definitely they are sliding. Correct. But in relative sense, observing B from A or observing the B point from A or A point from B, you will see the rotation. Now, I want to write down this equation for a vertically downward direction because I know acceleration of B is in downward. See, acceleration of A, what is the value of acceleration of A? This equation I am writing in vertical. In vertical direction I am writing. First of all, please understand, this is what vector addition. So I will only consider the vertical components, then only I can easily add. I am writing only the vertical components, then only I will get I can directly add these values. This is also vertical, this is also vertical, this is also vertical. So I will write vertical component of this one, vertical component of this one, and vertical component of this one. Then only I can do the basic algebraic mathematics here. Addition basically. Acceleration of point A in the vertical direction, 0. Acceleration of B in vertical direction given as 2. It is given as 2. Fine. Plus, okay, better I will mention the directions here so that it will be easy for you to understand also. So for B it is vertically downward direction. So let us first, I will show you the direction. Acceleration of B, downward direction. Acceleration of A with respect to B, as it is having two components. First component is the tangential component of A with respect to B. Another component is what, normal component, A with respect to B. Now, how I will write first for tangential component. So let us draw some coordinates here. So acceleration of point A with respect to B. So at point A I have drawn this coordinate system. Why I have drawn? Because I can easily identify the directions. Just for my convenience I have drawn like this. Tangential, so sitting at point B, observing A, so it will have a tangential component like this, perpendicular to the rod AB. Is this point clear? Let me write it with different color. Tangential acceleration of A with respect to B is perpendicular to this rod, right? Perpendicular to this rod. So this angle was 30 degree. Okay, from the vertical it will have angle 30 degree like this. Okay, fine. Now next for this normal component. Now normal component means always this acceleration have a direction towards the point of rotation. So from point B I am observing A, so normal acceleration will be towards point B. Now see how I will draw, towards point B. So along this ladder direction only, this is having 30 degree like this. So for this one, this is the direction, for this one, this is the direction, and this point is what? This is point A. This is point A. For point A, I have written this accelerations. Now we will write the values here. Done. So please carefully observe this part. right, acceleration of B already it is given 2. But tangential acceleration, how you will write? R alpha. R alpha, but vertical component we need to write. So R alpha cos 30. Here R omega square for normal acceleration. R omega square sin 30. Right. So finally we will have an equation like this. 0. The value of acceleration of B is 2 plus acceleration of this one. But it is vertically upward, so I will write negative. R into alpha cos 30 plus this one also will have a vertical component in upward direction, so again negative. Normal acceleration is written as R omega square into sin 30 like this. Now omega already we have solved. Alpha is the only unknown in this equation. So from this one we can easily get the answer of alpha. Only unknown in this particular question. So please everyone try to solve this one and tell me your answer. Let me know about your answers, guys. Mention in the chat box the answer. So this approach is very important, and let us mention here also the normal component of acceleration. At point B you are sitting and observing A. So A will be under rotation, tangential acceleration, normal acceleration. So by drawing this diagram, no, you will not do any mistakes. So this diagram is just for my own convenience, so that I will take correct directions and I will not do any angle mistakes here. Okay, so definitely it will take some time, but I will be getting the correct answer. So what is the final answer after solving this one? Omega we have already solved. What was the omega value? Okay, omega value, you have not told me the what is omega value you are getting. 0.288, please mention it as 0.288 radian per second. 0.288 radian per second. Now next is what? Alpha value. Correct, that is omega value, na? That is omega value, but here alpha value I am asking. So you can cross check your answer. Approximately 0.096 radian per second square. Approximately this will be the answer. So just cross check with this answer whether you are getting same answer or not, please everyone. Done? Is it done? Yes or no, Vinay? Tell me. And this is most expected question I am telling you guys. Angular acceleration problem in the gate. R value will be what? Tell me, what is the R value? From B you are observing A. So what is the R value you will use? From B you will observe A. So distance between A and B will be the R, na? That is 16 meter. Clear? 16 meter will be the R value. Yes, 16 is the correct value. So you will put it here and you will get the answer. Okay, so let us move to the next problem. This one. This one is like a direct formula based. You should know the formula and you will be easily get the answer here. So there is a complete derivation involved in this one, but we'll not go into the derivation part. So the only thing is you should remember the direct formula here. There are two formulas in this particular question. So see, there is an elastic sphere which is dropped from certain height, right? What they are asking, the calculate the whole distance that the particle will have before it is finishing the rebounding, and also the time taken, total distance it would travel, and also the time taken for that till it has completed his rebounding. After that it is not again rebounding. Till then what is the time and what is the distance it has traveled? That is what they are asking. Okay, so let us try everyone. I hope you remember the formulas in the revisions, gate revisions sessions. I have discussed those formulas. I have discussed those formulas, guys. Let me write it for you again. It is 1 plus E square divided by 1 minus E square into H. That is the distance traveled. Okay, so just you need to put the values and you will get the answer. 0.09. Yes, I think you are talking about the previous problem. Yes, 0.096. Approximately it is 0.09. Done. And the time taken here will be 1 plus E, 1 minus E, okay, under root 2H by G, like this. 1 plus E divided by 1 minus E into root 2H by G. Okay, so these are the two formulas that you need to remember, guys. Okay, accordingly you will get the answer. So let me just tell you the final answer here. Okay, you can cross check later also, or better keep that one as homework for you. You will do it. That is not a big issue. Okay, we'll move to the next part. This is direct formula based questions you can expect. Distance, total distance traveled and the total time taken for that movement of the total time taken for that, like till it has finished the rebounding. Till then how much time it will take, that you can calculate from that formula, and total distance it will travel from this formula. Now the final and the last question that we are going to discuss here is this one. This is very, very, very important, and I know personally that many people have faced so many challenges in the question itself, right? So from the basic I will tell you this question part, but first of all you should understand how to get the answer, the time required for which the ball will start rolling. Okay, so they are asking basically the time at which the ball will start rolling without sliding. So what happens here, they have simply projected a ball with a linear velocity, no angular velocity has been given. Without any angular velocity we have projected. So after some moment it will start rotating. It will have rotation, but at what time it will actually have a pure rotation, a pure rolling motion actually, not rotation, pure rolling motion. So you have given velocity v0, linear velocity, it will slide for some distance, then it will start rotation. Rotation started, but at what time it will have a pure rolling motion? That's what they are asking. So first I will, again same thing I will do here. I will draw the free body diagram here. Let us draw the free body diagram. Okay, let us draw it here. Now see, this is the normal reaction it will have. This is the weight mg it will be having. This is the linear velocity v naught it will have, right? Okay, so this is the v naught velocity, this is the weight mg, this is the normal reaction. Now see, after sliding it will start rotation, but the point is what? The pure rolling motion. And what is pure rolling? That is the basic difference, basic definition part you should know. Pure rolling means what? The center of mass of that particular body should have a r omega velocity and acceleration will be r alpha. And one more thing, pure rotation we can call it when this point of contact is having a zero velocity. The point of contact should have a zero velocity. That is basically the meaning of pure rolling motion. Or we can say rolling without slipping. So point of contact should have a zero velocity. So linear velocity here also r omega. Okay, this angular velocity also r omega here. Both will get cancelled out. That's why it is having zero velocity. So whenever it is having a pure rolling motion, remember point of contact should have a zero velocity. This is the first basic thing you should know. Okay. Now coming to the next part. Friction force will be coming here. Mu into n. Got it? Mu into n is the friction force will be there. Now apply equation of motion here. Summation of forces equals to mass into acceleration. Okay, what is the force here? Only force involved here is mu into n. That is 2 in left direction, so we will take it negative here. M into acceleration a. So n value, what is the n value? Mg only, because if I take summation of forces vertical 0, mg equals to n. So from here acceleration value you will be getting, mm will get cancelled out, so minus mu g is the acceleration. First thing we have solved. Okay, that is linear acceleration. Summation of moment equals to I alpha. Okay, now please understand what is they have given. This is a solid sphere. For solid sphere, can anyone tell me what is the mass moment of inertia value? Can anyone tell me what is the mass moment of inertia value? What is the mass moment of inertia value for the solid spherical ball or solid sphere? Okay, this is very basic thing you should know. 2 by 5 mr square for solid sphere, and for hollow sphere it will be 2 by 3, and hollow sphere will have a more mass moment of inertia compared to solid one. So for solid sphere it is 2 by 5 mr square. Correct, Vinay, absolutely correct. Now friction force will create a rotation about the center. So it is basically applying a torque at the center. So this mu into n, friction force multiplied by the radius, we'll write capital R. Okay, no issue. Mass moment of inertia value 2 by 5 mr square into alpha. Correct. So RR will get cancelled out. N value will be mg. Okay. 2 by 5 m into r into alpha. M and m will also get cancelled out. Alpha value 5 mu g divided by 2r. Okay, 5 mu g divided by 2r, that is the alpha value. So first angular acceleration value we have solved here. Again, each parameters are important. They can ask anything. So this is the first parameter, 5 mu g divided by 2r. Is it clear? Yes or no? Just tell me, is it clear how we have solved this alpha value 5 mu g divided by 2r? Done? Now, so as I told you also this point, pure rolling means at this point of contact velocity should be 0. And how it will be 0? When the center linear velocity becomes r omega. Okay. So let us first write velocity v naught plus at. This velocity will write. Okay, v naught, that is what the initial velocity we have given. acceleration is what? Minus mu g into t. This is the velocity. Now if I talk about this one, angular velocity, omega equals to omega naught plus alpha t. Omega naught, what is the omega naught value? Initial angular velocity given in this question. Initial angular velocity given in this question is 0. So alpha, directly alpha value I will write here, 5 mu g divided by 2r into time t. That is what omega value. Alpha 5 mu g divided by 2r multiplied by time t. Now for pure rolling motion, V should be equals to r omega, right? Okay, so this is V naught minus mu g into t, r multiplied by omega. What was the omega value? 5 mu g divided by 2r into time t. Now this r will get cancelled out here. So V naught mu g into t equals to 5 mu g into t divided by 2. So V naught equals to 5 mu into g divided by 2 plus mu g into t. So finally from here we will get the answer of time t as well. So if I take the LCM here on the right hand side, okay, if I take the LCM on the right hand side, so it will be 7 by 2 mu g into time t. So finally time t answer here, okay, it is 2 V naught by 7 mu g, correct? 2 into V naught divided by 7 mu g is the final answer here, correct? So this is what the time required for the pure rolling motion to start. So I am telling you such type of questions, it might come, maybe not exactly in this format, maybe some another parameter they are asking, but the concept you should remember. Yes, Vinay, absolutely correct. 7 by 2, no, it is 2 by 7, na? 2 into V naught divided by 7 mu g. Okay, right hand side answer you are telling 7 by mu g into t. Got it. Yes, so time required is this one. Now, one thing that last part I want to tell you here is, in such type of question, time required for pure rolling, okay, velocity or angular acceleration like we have solved, this can also be asked. This thing can also be asked. Velocity v after some time t. T value, let's suppose they have given 3 seconds, they are asking linear velocity. After time t, what is the angular velocity? See, 3 to 4 questions can be created from this simple example. So this example that I have discussed, from this one only 4 to 5 question I can create right now. See, calculate the angular velocity. Same question, everything will remain same. In this question, calculate angular velocity after time 2 seconds. We'll get the angular velocity using this relation. Calculate the linear velocity after time 2 seconds or 3 seconds. Linear velocity also we can calculate. Calculate the angular acceleration. We can calculate. Calculate the time required when the pure rolling will start. So 3 to 4 questions can be created from single example. So guys, please try to understand, we have to solve questions, that standard question we should solve, and from that standard question we should understand any other variety of question coming from that standard question, we should be in a position to solve those questions. So always during practice we have to solve standard questions, and this is one of the standard question. Within this question 4 sub parts can be created. Okay, I hope, I think this question solution is also clear. Is it clear? Vinay, can you just let me know whether it is clear or not? So almost we have discussed the 10 questions, right? Almost we have discussed total 10 questions. So please have a practice. In the last time we have to practice important standard question. Revision doesn't mean that you have to read only. You have to practice, you have to solve some standard questions, right? So I hope you have enjoyed this session, right? So if you have enjoyed, you can share this session with your friends also. And in tomorrow's session, I will be taking theory of machine questions. So please be ready for the theory of machine session also. Tomorrow I will be taking. So now I will end this session here. I hope you liked the session. Thank you so much, guys. Thank you so much. Bye-bye.